Hi guys, today we're going to look at logarithms. I know some of you have already seen them before, but it's been a while. Others of you said you have not, so we're going to act like you haven't. If you look at the standards or the things that were on your test review for your final, you'll see that there are quite a few things that have to do with logarithms. And so between logarithms and exponentials, we will be taking up most of, well, all of this week and most of next week. Okay, so also, I did mention about the possibility of live streaming. That is not going to happen. Okay, it just does not work at my house, and that's just where I need to be. And it's just hard to keep a schedule enough to say that this is when I'm going to be live. Okay, that does not mean, however, that I'm not willing to get on Zoom with you one-on-one or a group of you and go over the lesson or help you with your homework, whatever you need. Okay, so Zoom is an option, just not live conferences probably, okay, or live streaming. So let's go ahead and get started with logarithms. Okay, so first off, logarithms are inverses of exponentials, and that means when we go to do exponential equations, we'll be using logs sometimes, and when we go to solve logarithmic equations, we will be using exponentials some of the time. It just depends on the situation, but they do undo each other. And one key thing you need to remember is that logarithms themselves are exponents, okay? So exponents can be positive, they can be negative, they can be fractions, they can be zero. So when we talk about a logarithm itself, okay, the overall quantity can be positive, negative, or zero, or a fraction, okay? And so we'll be looking at that a little closer today. Now, what we want to look at is the different forms. So this form is our exponential. Okay, so we have y equals b to the x. And that's what we looked at for a day or two last week. Okay, we said that this b had to be a bigger number than 1. Okay, or it had to be between 0 and 1. We didn't care which, but it had to be positive, and it couldn't be 1, it couldn't be 0, and it couldn't be negative. Okay, so that was our base. And then we had our x, okay, which was the exponent. Okay. And then we had what we always have, we have that y. Okay, so what y is equal to. So this is the exponential that we have been looking at the past few days. Okay. Now, when we look at it as a logarithm, though, logarithmic form, okay, we rewrite it, okay, and we're concerned about the exponent, okay. So the exponent is equal to, we take the log, okay, so that's how we write it, log base b, okay, of y. Okay, so we have an equivalent logarithmic form, okay, and that's where the x is down here, okay? And notice that is an exponent, so when we talk about a logarithm, we are just talking about the exponent, okay, but we have log base b, okay? And so notice the b came from here, and that is a subscript, okay, so be careful with writing it, and it's equal to, or it's of, okay, what y was, okay. And I know that seems kind of weird, and we are going to practice rewriting today. We're going to practice actually finding out what this is today with our brains or a power chart and with a calculator, okay. So one side note is this is read as log base b of y, okay, is equal to x. Okay, so when we see a logarithm, that is how we read it. Okay, so log base b, that little subscript, okay, of y is equal to x. Okay. So what I want us to do in this part 1 video is just go back and forth between the logarithmic form and the exponential form. Okay, so we're going to go back and forth between the forms. So let's try as an exponential. So when we write it as an exponential, when we're going back and forth between the forms, you're not trying to solve anything. You're not trying to find out what an answer is. You are just rewriting. Okay, so we're getting comfortable with what it actually means. So don't go trying to solve anything. We are just rewriting. So let's say that we have log base 2 of 8 is equal to 3. So if you'll notice here, there's no x's. There's nothing to solve. Okay, so this is in the logarithmic form. We have log base 2 of 8 is equal to 3. And we want to write it as the exponential. Okay, so if you think about it, when we write an exponential, the first thing we need is our base. So where do we find that base? Well, it's that little subscript here. So we have 2. Now we need that base to be to a certain power or exponent. So where do we find that power or that exponent? Okay. Well, in a log, that's what we are equal to. Okay. So we are equal to that 3. So 2 to the third, and what was that y value, or what were we equal to? We were equal to 8. And this one actually does tell us that we're right, because we do know that 2 to the third is equal to 8. Okay, so this is the logarithmic form. This is the exponential form. Okay, now some people have a little trick for remembering this. They do an e. Okay, so they start with the base, they go across the equals, and they hit that exponent, and they make an e. So we'll see what that looks like. What about log base 1/4 of 16 equals -2? So we want to write it as an exponential. Okay, so what was the first thing we needed as the exponential? We needed our base. Okay, and so remember, our base is our subscript here. So we have 1/4. Okay, and then an exponential needs an exponent, and that is our -2. Okay, so we have 1/4 to the -2. And then it's equal to what? Well, it's equal to that y. Okay, or what the of part was. Okay, so equal to 16. And a side note, this is true. Remember, a negative exponent flips it, so we have actually 4 to the second, which makes 16. But again, here you're not solving anything, you are just rewriting. And again, that little e trick, I go here and make an e. Okay, so 1/4, -2, 16. So why don't you try this one? Pause the video and try it, and then come back and check with me and see if you are correct. So actually, let's change that. That's not a good one since, excuse me, that's not a good one since it has 2 different things. Okay, so why don't you take log base 3 of 1/27 is equal to -3. So go ahead and pause the video, try it, and then come back and check with me. Okay, so our base here is 3. Our exponent is -3. And what we're equal to is the 1/27. Okay, so we have 3 to the -3 is 1/27. Okay, so that's what it should have looked like when we rewrote it. Okay, so if you have questions about that, now would be a good time to email me, either ask for a conference or just ask for some clarification. Okay, so let's go the other way. And we want to write this as a logarithm. Okay, so what about if I have 7 squared equals 49? Okay, and again, we're not trying to solve anything. We are just rewriting it. Okay, this is the exponential form because I have a base to an exponent equals the 49. So when we go write it in logarithm form, we write log. Okay, and then we have to go find our base, which is right here, and it becomes our subscript. So log base 7 of what? Well, the of is that y value over here. We always go across that equal sign to get our next one. Okay. Equals, and then exponentials are, exponents are what logs are. And so it's equal to our exponent, which is 2. Okay, so here we have log base 7 of 49 equals 2, and that's the logarithmic form. Okay. There is a little way to remember this one as well. Some people make like an L. I know it's kind of a funny L, but that's how some people try to remember it, or maybe even a G for log. Okay, but let's see if we can do another one. Let's say 5 to the negative 4th is 1 over 625. So to make this a log, we need a log and a base. Our base is 5. Okay. Of what? What number do we get as an answer? Okay. And it's a 1 over 625. And then what is our logarithm, or what is that exponent? It was a negative 4. Okay. So, and again, if you wanted to do the little help, you would start at the 5, we go across, and then come to the exponent. Okay. So again, I would pause and try this one, and then check it with mine. So let's say 6 to the 3rd is 216. Okay, so pause your video, go look and try this, and then check with mine. Okay. And here we have a base of 6. We have it of 216. And we are equal to the exponent of 3. Okay. You should see that I included an exponential chart in the notes, just a power chart. Yes, you can use your calculator to figure these out. The more we do them, the more comfortable you'll get. Okay, but it is a power chart, and I'll leave you instructions on how to do that. You just read it across and down. Okay, I believe is how I set it up, but I'll make sure it's noted on that. Okay, so one other thing before you take a break and practice these is that we have 2 special types of logs. Okay, and so the first one is called the common log. And this is when you have a base of 10. Okay, so a common log is when we have a base of 10. And you don't have to write that base. Okay, it's also the log that's on your calculator. Okay, so we do like base 10 logs. Okay, so this log here is a base 10 log. So that being said, like if I have 10 to the 3rd, that's equal to 1,000. Okay, so if I want to write it in logarithmic form, excuse me, I can write log base 10. However, you do not have to write the 10, and we try not to. Okay, it's like writing that 1 in front of an X. It's not needed. Okay, so we don't write. Okay, although I won't count it wrong if you do, but it's best if we don't. Okay, it's just better math writing. So log base 10 of 1,000, okay, is equal to 3. Okay, so that's the common log. Okay. Or if I have 10 to the negative 1st is equal to 100th. 1/100th. Okay, so I have log, we don't write the 10 of 1/100th. Okay, it's equal to negative 2. Conversely, if I work backwards, let's say I have log of 10,000. If I ask you to write that as an exponential, we go to look for a base and there's not one. Okay, but what do we know if it's not there? Okay, it's always 10. So 10 to the, whoops, I forgot that, sorry. So 10 to the fourth is equal to 10,000. And if you wanted to check in your calculator to make sure that you can use it, go ahead and try that right now. Push log and then 10,000. We should get 4. So that's what the log button is. It's a base of 10. Okay, so if you look right above, or excuse me, right below the log, we have ln, okay, and that's the natural log. Okay. And the natural log is a base of e. So you remember that letter e that we talked about, that 2.72? Okay, well, it's associated with the natural log. And on our calculator, it actually gives us a hint. Okay, so we have log, we have natural log. And if you look at the second function of those, right, our shift or our second, you'll notice that on natural log, it has an e to the x power, and on log, it has 10 to the x power. So they are putting those together for you. So your calculator kind of like gives you a hint. Okay, so natural log is a base of e. So something like e to the x is equal to y. Okay. I know I don't have numbers in there, but you can still rewrite this. Okay. As soon as you see an e, what do we know the base is? Sorry, what do we know it's referred to? It goes with the natural log. So natural log of y, okay, is equal to x. So when we have a base of e, it goes with natural log, not log. Okay. Or e to the 0 is equal to 1. Okay. I'd have natural log of 1 is equal to 0. Okay. Going the other way, if I have natural log of y is equal to 5, well, what do I know the base is when I have natural log? Well, it's e. So I have e to the 5th is equal to y. Or if I have natural log of a equals b, whenever I see a natural log, I know that e is the base. So I have e to the b power, okay, is equal to a. So natural log goes with e, and the common log goes with 10. Okay, so what I would like you to do now is take a break, and then in your book, try page 399, 1 through 18. And all it is rewriting, okay? And I'll have the answers posted for you on Google Classroom just for you to check, okay? So you're not turning this in, but you are practicing, and I do expect you to be able to go back and forth between the two forms, okay? So when you're ready, go ahead and head to part 2, and that's where we'll make sure we know how to evaluate with and without a calculator.